Welcome to the first module. In this module, we'll learn about how to use data science to solve a practical problem. And we will also introduce our first machine learning algorithm, namely linear regression. Regression is the workhorse of data science, business analytics, and research. You'll find people using regression whenever someone is looking to model a phenomenon or make a prediction or discover the hidden relationships among things. Also, I want to show you how to solve problems using data science. So what kind of problem are we going to look at? Well, imagine that you're a film producer. You provide money to make movies. And when the movies make money, you make money. And when the movies lose money, you lose money. But today you discover a problem. You found out that you just put a whole bunch of money into a movie called Zombies Rise Again, Part 5. And if that doesn't sound like a terrible title for a film, then I don't know what does. Worse yet, you've staked your reputation on this film. You've mortgaged your house. You've sold your car. You've sold your grandmother's silverware to fund this film. So is your money gone? Will you go bankrupt? Well, to answer these questions, you would have to be able to predict the future. And this is where data science will come to the rescue. Let's have a think about how a data scientist would approach this problem. Well, first, a data scientist would carefully formulate the question that they're looking to answer. Why? Well, a clear and well-formulated question will determine the research, and it will also affect the kind of data that you will go out and gather. In fact, step 2 is gathering the data that will help us answer the question. But real-world data is also messy, so we have to clean the data. We have to look out for missing data or incomplete data. We have to look out for errors and even bad formatting. In fact, we have to explore the data that we've gathered. And often this means visualizing the data so that we can better understand what it is that we're working with. A graph or a chart is much more helpful than a table of numbers. And after we've done all that, the next step is actually training our algorithm, using our computer to identify patterns in the data. In our case, that algorithm will be our linear regression. And finally, we have to evaluate the results. How did our algorithm do? Did it answer our question? How accurate was our algorithm in answering our question? The process that I've outlined here is the process data scientists use to solve problems. This is their workflow for understanding and making sense of the world. So let's tackle that first step. Let's formulate our question. So here's our first shot at this. How much money will our movie make? Now, this is actually not a very good question. The problem is that this question is too vague. For starters, what do we actually mean with the word money? Can we be more specific? How about this? How about how much revenue will our movie make? Now, this is already a much better question, because revenue is something that means something very specific in the business world. It's something that accountants actually measure and track. And that means that we can actually find data on movie revenue. But what does movie revenue actually depend on? Let's have a think about this. Maybe it depends on the actors. Do movies starring Scarlett Johansson do particularly well? Or maybe it depends on the script. Or maybe what actually matters is the film's overall budget. Because after all, you have to pay good actors, and you have to pay for special effects, and marketing costs a lot of money too. So maybe the overall budget would be the best thing to look at. So if that's the case, then we have a hypothesis. The movie budget could indeed be the thing to investigate. After all, there are many famous examples of big budget films that did exceptionally well at the box office. Movies like Avatar, Titanic, and The Avengers cost an absolute fortune, but they were enormously successful. But can the success of these movies tell us something about the success of our movie? If we knew how much movies like Avatar, The Avengers spent and how much they made, can we predict how much we'll make based on how much we're spending? So let's go back to our original question and let's make it a little bit more specific. Can we use movie budgets to predict movie revenue? Now, that's already a much better question. Why? Well, it's testable. And by testable, I mean that we can actually check if there is a relationship between movie budgets and movie revenue. This is something that we can measure using data and linear regression. And as data scientists, we can actually look at this question and identify exactly what it is that we're trying to predict, namely the movie revenue. A data scientist would call this the dependent variable. And in machine learning, this would be called the target. Also, we can identify what it is that we're using to make the prediction, namely the movie budgets. A data scientist would call the budgets the independent variable. And in machine learning, this would be called a feature. So now that we've formulated our question, we can move on to step 2. We can go out there and gather some data. And we'll do just that in the next lesson. Now that we've defined and formulated our question, it's time to gather the data. So let's have a think about the kind of data that we're looking to gather. First off, we need data on our feature, namely the movie budgets in US dollars. The second thing that we need is data on our target, namely the movie revenue in US dollars. So where would we go about finding this kind of data? Well, lucky for us, there exists a website called The Numbers. And their slogan is, where data and the movie business meet. This sounds perfect for our project. So let's check it out. So this is what the website looks like. If we go to movies, budgets and finances, then we get the performance records of various films. And they've even got some tables here on some common searches or common questions that people might be interested in. For example, they've got the biggest budget films right here. And if we scroll down, they've got the movies with the lowest budgets to earn $1 million at the US box office. And I think a notable film here is El Mariachi, which apparently only had a production budget of $7,000, but made about $2 million in the US box office. If we click on this link here, where it says the complete list, then we get the entire table of all the films in the database right here. And this table is actually enormous. It's very, very long. There's quite a few different entries here. And what I've done is I've selected all of these and I've copy-pasted them into a spreadsheet. Now, to save you this kind of tedious work, I've made a CSV file available under the lesson resources. All you have to do is download it and open it in Excel or in Google Sheets. And once you open this file, what you should see is the movies sorted by their rank. So at place number 1, we've got Avatar, then a Star Wars film, then Pirates of the Caribbean. All of these films are sorted by their production budget, so column D. And if we scroll down, then we can see that there's a lot of entries in this file. As a matter of fact, there's about 5,000 entries in this CSV file. So this completes our data gathering step, and we can move on to the next part of the workflow, namely cleaning the data. So let's take a closer look at what we've actually got. If I scroll down here, then I can see there's a lot of numbers, but occasionally we might spot something a little bit odd. For example, here in columns E and F, we have 2 big fat zeros. Scrolling up, I can see these are the columns for worldwide gross and domestic gross. And yet, this movie entitled Singularity, with a production value of $175 million, has 0 revenue. And the reason for this might be found in this column, our second column here. What we have here is the projected release date. So end of 2020 is when this movie is due to be released according to this data set. And what they've done is they've put a placeholder of 0 into these 2 columns instead of removing this movie entirely. So they've included it in the data set with $175 million production budget. Because it hasn't made any revenue to date, they've added some zeros here. Now, this might actually be a little bit of a problem for us, because we're looking to make a prediction for our movie revenue. And if our data set is going to include films that have not been released yet, and have big fat zeros for the revenue, it might make our estimates a little bit unreliable, right? So one thing that might actually be worth doing is checking how many films out of the 5,300 actually have a revenue of 0. And we can do this by sorting by worldwide gross. If I select my data here and then open the menu and go to Data, Sort Range, then I can actually sort by column number E. And since we don't want to include that first row in the sort, I'm just going to tick this box here and then click Sort. And what we see here is that there's quite a few films that have a 0 entry for worldwide gross and domestic gross. Now, why might that be? Well, for some of them, the release date is in the future. But looking at this column, we see that not every film that has a 0 here is due to be released in the future. So for example, this one here, Blackwater Transit, was supposedly released at the end of 2008. And this film also has a big fat 0 in worldwide gross. Why might that be? Now, one possible answer is looking at the description of the website. So if we go here, then we see this line. The data, to the best of our knowledge, is accurate, but there are gaps and disputed figures. So some of these zeros might be gaps. It might just be that the data is incomplete for some films. But I've actually looked up this Blackwater Transit film, and on Wikipedia, I can see that in post-production, there were actually quite a few lawsuits, and there was quite a lot of back and forth between the production company and the filmmakers and the producers and so on. So this film actually never got released. And this release date here of end of 2008 was probably a planned release date, but the movie actually never came out. Now, this might be something that happened to quite a few of these films, and they might have a 0 for various other reasons too. But this poses a big problem for our analysis. If we're looking to predict movie revenue based on the budget, then having these 0 entries here is going to be a problem. So what I would suggest, given that some of these films were probably not released, other ones the data might not be available, is that we should actually exclude the films that have 0 here for worldwide gross and domestic gross. We should select all of these entries and delete them from our dataset. So if I come down here to row 358 and scroll all the way up, then I can select all of these rows, I can right click, and I can delete the rows. We're going to exclude these rows from our analysis. The next thing that we're going to do is we're actually going to have to do some calculations. And these involve the production budget and the worldwide gross. These other columns we're actually not going to use. We're not going to use the domestic gross. We're not going to use the movie title or the rank or the release date. So what I would suggest is that as part of the data cleaning process, we're going to delete these entire columns. So we're going to delete these columns and we're going to delete this column right here. That way we can trim our spreadsheet to what actually matters for our analysis. The next thing that we need to do is we need to have a think about these special characters that might be in the data set. And by special characters, I mean anything other than a number. So we're going to be doing some calculations with all of this data, and those calculations might be troubled by the fact that there's a $sign here or a comma. This type of formatting could cause problems. So it's better to remove it and have a pure number in these cells rather than all this extra stuff. And the way that we can format all these numbers and get rid of these symbols is by selecting the columns, going to Format, Number, and then scrolling down where it says More Formats and going to Custom Number Format. And here we can pick the second one down, which is this decimal number, and click Apply. Now we've got no more $signs in our columns. So we're almost done cleaning our data. The last thing I'm going to do is I'm going to rename my column headings. And the only reason I'm doing that is because I'm going to remove spaces and these custom symbols here, the parentheses and the $signs, from the headings to make our lives a little bit easier on. I find that as soon as I have special symbols or white spaces in my headings, I make a lot more typos when I refer to particular columns. So for this one, I'm just going to call this production _ budget _ USD. And this one here, I'm going to call worldwide _ gross_USD. With these two names for our headings, I've got very expressive headings, and yet there's no white space and there's no special characters. This will make our life a little bit easier down the line. So in summary, for the data cleaning, what we've done is we've looked for missing data, we've looked for incomplete data, we've looked for inaccurate data, and we've done some tidying up by checking the formatting of our data in detail. And the reason we've done all of this is so that we don't have problems when we provide this data to our machine learning algorithm down the line. Now we can move on to the next step, which is exploring and visualizing our data. Mind you, if we spot any more problems during this next step, we might have to do a little bit more cleaning as well. So you'll find that very often in practice, you're going to be doing the cleaning and the exploration side by side.